Okay, what I'm gonna solve now is gonna be the problem 1023, and it's talking about a wheel that come off a moving truck and roll out without slipping along the highway until it counters a hill like this, and it's go from here up to the hill until it stop over here and the elevation of h. So at the beginning, this will have an angular velocity of 25 radians per second, which is here. The weight of the wheel is 397 newtons, but for purposes of the problem, we're gonna need the mass of the wheel, which is, you can find it easily dividing the newtons divided by gravity, and it gives us 40.5 kilograms. Another thing that we know is the radius of this wheel, which is 0.600 meters, and the moment of inertia that is given by the problem, it is 0.800 mr squared, where m is equal to the mass and r is a wheel radius. Another thing that we know is the friction is doing some work, a work of 2,400 joules. So for this problem, we know the wheel initially have a rotational and a transitional kinetic energy, then stop here at the height of h. And for knowing that, we can use the energy conservation law, which is the following: is kinetic energy initial plus potential energy initial plus work of others equals to kinetic energy final plus potential energy final. We know at the beginning of the hill there is no potential energy, so this cancels out. And at the top of the hill, there is no kinetic energy final. This is cancels out. Another thing that we know, that the work of others is a friction doing work over here. So since the wheel, like I said, have a translational rotational motion, the kinetic energy goes like this. Kinetic energy initial is going to be 1/2 of the moment of inertia times the angular velocity square plus 1/2 mass velocity, linear velocity square. Another thing that we need to change is going to be the linear velocity. We know that linear velocity is going to be equal to angular velocity times the radius. So then this whole formula over here is going to end up like this. It's going to be 1/2 moment of inertia angular speed square plus 1/2 mass angular velocity times radius square plus work of friction equals to mass, gravity, and h. So what are we looking here is what is the h value where the wheel stop. So putting this together with this, we ended up the h is going to be equal to 0.9 mass radius square angular velocity square plus the work of friction over the mass times gravity. We need to know over here that the work of friction is against it, so it's going to be negative. And then we put all the values that we know in here. It's going to be h equal to 0.9 m is the mass of the wheel, which is 40.50 times the radius 0.6 square times the angular velocity square minus the work of friction, which is 2,400 joules. This divided by the mass times gravity. And this is going to give you h equal to 14.61 meters, and this is the answer of the problem. Thank you.